Hi, my name is Tyler Vance. Today I'm going to be talking about Wolff's Law and briefly touch upon some soft connective tissue. So to start out, before I talk about Wolff's Law, I want to explain the three different major types of bone cells in the body and their functions. We have osteoblasts, which are bone builders. I remember that because osteoblasts, the B, means build. Osteoclasts are cells that break down the bone. So it has a C, so that reminds me of cut. So cut down bone cell or bone tissue. And then osteocytes, which are for bone maintenance. So basically osteoblasts, a good thing I like to think of is imagine a brick builder. An osteoblast is someone that builds up a brick wall. He adds the bricks or the bone matrix and builds up the bone matrix. An osteoclast takes it down when needed, and an osteocyte is the maintenance man. So whenever there's a broken brick or a cracked brick, he will take the brick out and replace it with a new one. Now you might be wondering, how does that relate with Wolff's Law? Well, Wolff's Law states that when there is pressure applied to a bone, that causes the bone to be built up, or a growth in bone tissue. So, and that happens through the piezoelectric effect. What happens is when there is a pressure or a strain applied to a bone, a signal is sent, an electric signal or the piezoelectric effect, to osteoblasts. And these osteoblasts then begin bone tissue build. It's kind of like a remote control for a television. When you apply pressure to the button or pressure to the bone, it sends a signal to the television, and that causes an action, or in this case, bone building by the osteoblasts. Now for soft connective tissue, I'm just going to briefly touch upon some important different tissues that you're going to talk about throughout your kinesiology course. We have the ligament, which is a connective tissue that connects bone to bone. The tendon connects muscle to bone, and the retinaculum, it's almost like a bracelet or an anklet. You have these in your wrists and your ankles, and their purpose is to hold down tendons against the arm or the leg in this case. You can imagine you have various muscles and tendons attaching to the bones in your hand, and when these contract at this angle, you would see almost the tendons would come sticking out because they want to take the shortest path. But retinaculum holds those tendons down to help with that line of pull and to keep it so that you can reach for things and are more effective in your movements. A tendon sheath works with retinaculum sometimes. Basically what a tendon sheath is, a protective covering for tendons, just kind of like the name tells you. I like to think of it as I like mountain biking, so a cable or a protective rubber casing on my cables. When I press my brakes, the cable contracts and pulls, and the casing protects my cable from wear and tear up against my legs or other parts of the bike. Same with tendon sheaths. The tendon sheath cases the tendon so that when the tendon is contracting, that it doesn't rub and protects it from overall wear and tear. Aponeurosis is basically a tendon, so it's connecting muscle to bone, but it's called a flat expansion of tendon. So you'll see examples of aponeurosis in your abdominals and in your lower back, called your thoracolumbar aponeurosis. And the last soft connective tissue I want to mention is fascia. Fascia is almost like a shrink wrap around various parts of your body. Basically its purpose is to protect the section of your body that it's covering, and also separate it from other parts of your body, and it also protects against the transmission of disease as well. If one part of your body is infected, the fascia covering the other part will help it so that part doesn't get infected as well. An example of fascia, your back, you have superficial, intermediate, and deep back muscles, and you'll actually have fascia in between all of these layers, separating the 3 different layers. So that's all I wanted to talk about today. Thanks a lot.